Paper of the day is Adaptive String Dictionary Compression in In-MemoryColumn-Store Database Systems. It's a 2014 paper. Looking at the summary, the paper studied the question of how to adaptively compress the string dictionaries of In-MemoryColumn-Store database systems. Their analysis of real-world business applications showed that strings are more commonly used than previously thought. In alignment with the requirement of a single tuple access of in-memory column stores, paper studied a broad variety of compressed dictionary formats. They found that for a single dictionary, there is always a trade-off between access time, construction time, and space consumption. In order to improve the space-time trade-off of the overall system, they built a compression manager automatically selecting the most appropriate dictionary format for every column, based on characteristics of the data, usage pattern of the column, and the overall system state. The compression manager uses elaborate compression models allowing to predict the size of a dictionary format for a given dataset using only a small sample of the data. Furthermore, the paper showed how to decouple local information needed for the format selection from the global information in order to keep the decision cheap. The paper evaluates an offline prototype of a compression manager using a variation of the TPC-H benchmark. The compression manager can configure the database systems to be anywhere in a large range of the space-time trade-off with a fine granularity, providing significantly better trade-offs than any fixed dictionary format. Now, looking at the contributions of the paper, there are three. First, paper surveys several approaches and variants for dictionary compression, that is, data structures that store the dictionary of domain encoding in a compressed way. As expected, there is a trade-off between the size of the data structure and its access performance. Second, paper presents non-trivial sampling schemes for all our dictionary formats, enabling to estimate the size for a given column. This way, it is possible to identify compression schemes specialized for the content of a specific column. Third, paper drafts how to fully automate the decision of the dictionary format. They sketch a compression manager that selects the most appropriate dictionary format based on the column access and update patterns, characteristics of the underlying data, and costs for setup and access of the different data structures. Now, let's give this paper a PS score. Overall, it's very bumpy read. There's quite a bit of math, so it gets 5 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. Reproducibility will be challenging, so it gets 6 out of 10. Industry value and learning is decent, so it gets 7 out of 10 on each. Overall PS score is 7 out of 10.